joke. I'm a recovering building official. Oh, letting me know it's being recorded. So be careful what you say, although I've already kind of ruined my name on several other YouTube videos already. So twice won't hurt. But was a building official before that. And I grew up in construction. So I've always kind of had that construction bent in my life, so to speak. But have gone from, wearing the nail bag to writing the red tags. And now I'm a tree hugging hippie working for an energy efficiency nonprofit trying to save energy. Well, those of you that don't know about the energy code. So, and again, I know we have a handful of inspectors on there. This webinar is not meant for somebody that works in building codes all day. This webinar is just a very 101 rudimentary level kind of what is the energy code. Now, certainly, feel free to stay on and you do get CEUs. So happy to have you continue, but it's not, if you're already well versed in the energy code, this will be nothing new. This is just really meant to kind of let folks know what it is, and then we will cover how to make your home more energy efficient. So I think Sean pretty much covered SPEER. We do cover Texas and Oklahoma. So, any way I can help you out. Actually, I had really anyone across the country or across the world. I had an email yesterday from some guy in Idaho that caught one of my YouTube videos and was asking questions about it. So the price is right. It's free. I'm a bit of a building code and building science nerd. And if I don't know the answer, having been with SPEER for 6 years now, I can certainly find the folks that do have the answer. So don't be afraid to reach out. You can see that was about a year ago, right there, a little over a year ago. Hadn't had a haircut in almost a year. The old Corona do, thought I'd throw that on there. Can't believe we're going through this again, it seems like. But again, today it's Energy Code 101, tips and tricks to save energy in your home, and then we'll save all the questions for the end. So let's get started. So the first question, if you want to throw up that poll, Sean. So what is a construction code anyway? Well, a code, so like we have an international plumbing code. It tells you how to do the water supply and drainage in a building. We have the National Electric Code. It tells you how to wire a building. We have the residential code, which covers the structural aspects of the building. You nails 4 inches on center in the perimeter and 8 inches in the field for the sheathing, for instance. And we also have an energy code. Forever was at SPEER, my title was Energy Code Program Manager. But we found that over the years, I get more and more questions about other construction codes as well as how to administer a building department, what forms the permit clerk might use for new construction. So just think about, and you don't need to launch the poll. Just think about how old is the oldest code. So that would be the oldest written code that said something about construction regulation. So you think it's maybe about 150 years old, which would be a product of the Great Chicago Fire. There we go. I won't continue reading them to you. I'll let you choose. And this has been on my webinars. Whenever I give a presentation to what I would call non-code folks, if you work in like sustainability or you work in whatever it may be, you're not typically dealing directly with construction codes. I think this is kind of a funny one to throw on there. Well, anybody that guessed 4,000 years would be correct. Almost 4,000 years, 3,774 to be exact. And we wouldn't need inspectors. It was actually the Code of Hammurabi. It was written on this tablet here, or this, it's like I don't know what it is. But anyway, there were, I don't remember how, 282 laws. And we wouldn't need building inspection departments if we had, for instance, law number 229, and I can speak correctly and write correctly. This is just how it translated. So it's going to, the English will be a little disjointed. But if a builder built a house for someone and does not construct it properly, and the house which he built fall in and kill its owner, then that builder shall be put to death. That would solve the problem of a lot of building departments, needless to say. It's like, hey, here's your CO with your permit. If you've screwed up this house, we're going to screw you up. But anyway, I just think that's kind of funny for our non-code folks. So let's get back to a little more serious actual code. So the energy code, here we see a timeline. The first one, the model energy code of 1986, actually ASHRAE 90 came along in 75, the model energy code in 86. The green line is ASHRAE 90.1, which regulates. So again, let me back up a step. So I mentioned, the plumbing code tells you how to plumb a building. Well, the energy code will tell you how much insulation to put in the walls, what should be the efficiency of your water heater or your heat pump, how many watts your mechanical ventilation can pull. So all of the building thermal envelope, the things that in Texas that keeps the hot out and the cool in, and the things that use energy in a building. And now commercially, it's a whole lot more complicated, of course. But so we look here, when we go through time with just increases in efficiency in the code. Again, the blue is the energy code and the green is 90.1, which 90.1 is actually an approved path through the commercial energy code. So you can choose 90.1 for your building to comply commercially. And it's actually a whole different energy code just specific to commercial. Well, and then there's also a commercial chapter in the energy code that you can use for commercial buildings. I'm a residential guy. I grew up framing houses in the Dallas area back in the, oh gosh, late 70s, probably. I was on construction sites with my dad nailing up the RMAX on the outside of the studs. So I prefer residential. I'll be talking about residential today. Here in a couple of weeks, I'm giving a presentation for the ASHRAE chapter over the commercial changes. And the commercial side is just so much more complicated. I really like to keep it simple. I'm a big proponent of the KISS theory. So I keep it simple and I like to focus on residential. But when I started with SPEER, the 2015 code wasn't the state code. House Bill 1736 made the 2015 energy code effective fall of 2016 for the state of Texas. Well, you see the stringency of the codes come along here, and this would be net zero down on the bottom, so using zero energy. Well, from the 2006 to the 2009 energy code, there was about an 8% increase in efficiency, 6, 7, 8, depending on building type, climate zone, things like that. And then from 09 to the 12, there was a big jump, 10, 12, 13%. And then the state of Texas came along with the 2015 energy code, which is almost identical to the 2012, the 2018, about the same. Well, here in 2021, we're taking a similar jump like we did from 06 to 09. It's about a 7, 8, 9, 10% efficiency gain, depending on building type. So as of right now, our state energy conservation office, and I don't have a slide about that, so I'll just talk about it. Our state energy conservation office. So House Bill 1736, and it's actually the Health and Safety Code 388, which directs our state energy conservation office to look at the energy code for adoption. And this all, in the very beginning, came back to it was from the TERP funding from the federal government for about improving air quality and reducing emissions. Well, if buildings use 40% of the energy, buildings are responsible for a whole heck of a lot of emissions from power plants, right? And so we realized, well, we can save a lot of energy by making buildings more efficient. And so our state energy conservation office is actually Texas A&M's Energy Systems Laboratory is tasked with reviewing each edition of the energy code and checking it for stringency. Does it save energy or does it not? Well, House Bill 1736 came along and modified the review and timeline. So codes come out every 3 years. And the builders and the efficiency folks kind of came together and said, the builder said, the efficiency folks wanted the 2015 energy code because it was the newest and most stringent. And the builders wanted consistency. So what they said, okay, we'll agree on the 2015 energy code, but we don't want to be messing with this again in another 3 years, because codes are published every 3 years. And I can tell you, as a building official, right about the time you figure out what's in the new codes, well, it's been 3 years and new ones are coming out. And oh my gosh, it would be so great if ICC would switch to 5-year cycles instead of 3, give folks time to get it figured out, but they don't. They come out every 3 years. And House Bill 1736 said the builders agreed to the efficiency of the 2015, and the efficiency folks agreed to, okay, we'll leave you alone for 6 years. That's what it amounts to. Well, we're here now at that 6-year time from when the 2015 became state law. So per state law, Energy Systems Lab, they've analyzed it. It is more stringent. Again, we already said it was about 7, 8, 9% more stringent. And so now our State Energy Conservation Office is at the point where they are soliciting comments, or they will be shortly, soliciting comments on the 2015 Energy Code. And then there was a little snag on a new piece of legislation, House Bill 2439, that has delayed, at the very least, moving the 2021 Energy Code forward. So we're at a little bit of a holding pattern from the State Energy Conservation Office's point of view for a statewide code, but we already have a handful of cities that have moved to the 2021. I gave a presentation last week, as effective September 1st, the city of Austin, for example, is now on the 2021 Energy Code. And if you're interested, I have a whole hour webinar on our YouTube channel about what's new in the 2021 Energy Code for Austin. And actually I have one on there as well, just generally what's new in the 2021. So all of that's available. Any questions you have about any of this, don't hesitate to reach out. I think we've covered that well enough. Let's keep going. So here's, how does the Energy Code work? Well, the Energy Code isn't going to make you build a house in Austin, Texas, the same way it is in North Dakota. So the Energy Code, the first thing it does basically is it breaks down the entire country, actually the entire world, into climate zones. Well, you see Texas here. This is Texas specific. We have climate zone 2. I don't get into A and B. A and B, this is the hot, humid line. So basically climate zone 2, climate zone 3, climate zone 4, they will have the same building thermal envelope requirements. But if you go further and further north, like North Dakota would be climate zone 7 and climate zone 8. You need a whole lot more insulation in the ceiling and in the walls in North Dakota than you do in Texas. And so that's the gist of how it works. The Energy Code through ASHRAE weather data breaks the country down into, based on heating degree days, what the climate's like. And so based on what that climate's like, you get what's called a prescriptive table for what you have to do. And these are the prescriptive tables. The one on the left is from the 2015 Energy Code. The one on the right is from the 2021. You'll notice the big difference in both the 2021 and the 2015. There's one of the biggest jumps is in between climate zone 2 and climate zone 3. So in Texas, the difference between building a house in Houston versus building a house in Dallas, if you're building it by these numbers, we'll look at this right here. This is the big one, the wood frame wall value. Well, builders like to use 2x4s for walls, right? Well, that's fine. You can get an R13 bat. These are R values. You can get an R13 bat and a 2x4 wall. Well, in climate zone 3, you go up to Dallas. Well, you need a 2x6 wall to get your R20, or an R13 plus 5. What that is would be like a continuous foam insulation on the outside of the studs. The neat thing about the Energy Code is it is super flexible, and builders in climate zone 2, even with the 2021 requirements, really have no reason to complain whatsoever. It's super easy. Climate zone 3 is a little bit different story, especially if you want to stick with your 2x4 walls and your R13 or R15 wall. Now the Energy Code will allow it. You might be looking at this table and say, well, how does it allow it? If a builder doesn't want to use this +5 continuous insulation and doesn't want to do a 2x6 wall, how do they allow it? Again, that's the neat thing about the Energy Code, is the flexibility. So there's multiple pathways through the Energy Code, so to speak. There's prescriptive, which is do these numbers on the chart, do all the mandatory items, get it tested, boom, you comply. Prescriptive total UA, which is what res check. Hopefully y'all have heard of res check. If not, it's a total UA calculator. And basically what it does is it looks at all of your windows, doors, walls, and ceiling and floors, and allows you, if you have a little bit less insulation in the walls, for example, like climate zone 3 will often have, well, no problem. We can make it up with a little better window. And so it takes it's the U value, which is just the inverse of R. R is what we're used to. So I like to speak in terms of R just because people are more accustomed to it. So it would take all the square footage of R that you're below code and take all this and take all the square footage of R that you're above code. And as long as you're trading off enough, so to speak, you would still comply. And that's what the res check calculator does. So if you had a whole bunch of really good windows in the wall that were 20% better than code, and you had your walls were 5% lower than code, then those trade-offs can be calculated. And then there's what's called performance path and energy rating index path. And what those two paths, it's like trade-offs on steroids, because it also on the performance path will include HVAC efficiencies and service water heating efficiencies. And then on the ERI path, you can also get credit for an Energy Star dishwasher and more efficient lighting. And so really there's a whole bunch of ways through it. It's super flexible for builders. Now, 7 years ago, 8 years ago, when I was building official in Granbury, and we went from the 06 energy code to the 2012 energy code. Well, what it did is it changed the paradigm. It was a paradigm shift, because energy inspectors, third-party energy inspectors, were not a thing in Texas. But once you have to test your ducts and test a blower door, so I don't think I have a picture of a blower door. So a couple of the things you have to do with the energy code that, I mentioned it is flexible, but there's a list of a dozen mandatory items, which when you hear the word mandatory, there's not a whole lot of flexibility there, right? So you have to do these things, right? And then there's testing requirements. And so what you have to do is you have to test your HVAC ducts, and they can only leak a certain percent. In the 09 was 12, and the 2012 energy code was 6. And then from the 15 energy code on has been 4% leakage. So if we're paying this money to condition air, we don't want that conditioned air leaking into our 140-degree attic, right? And then there's also what's called a blower door test, which is where basically you pressurize the house and you measure how much air leaks out of it. So you measure how leaky it is. So those two testing requirements have come in starting with the 2012 energy code. The ducts were actually 09. But anyway, so you punch all those numbers in the performance calculations, and boom, it tells you whether you pass or fail. And so you might have to add a little insulation here or there. You might have to do a little better air sealing here or there, or whatever it may be. So I know that's clear as mud. If you have any further questions about it, feel free to reach out. But really the gist of it is there's a list of mandatory items. There's a table that tells you how to do your air barrier install your insulation. And then there's these baseline numbers that you either have to meet or trade off. So that's basically the gist of how it works. And I remember when I started with SPEER, especially, I'd be giving presentations to builders about the changes on the energy code. And, it was gloom and doom for all the builders, right? This was actually in climate zone 2. So in the Houston area. Is it more expensive to build to a newer energy code? Absolutely. It costs more money to build a better building. However, this table is a little confusing. This is out of the Pacific Northwest National Labs calculations. But all you really have to know is, look, it's about $2,000 more to build a house to the 2015 versus the 2009 energy code. Well, $2,000, if you're financing your house over 30 years, that's going to add $7.50 to your mortgage payment. Well, if you save $17 on your energy savings per month, quite literally from the very first month you own that home, you're putting an extra $10 a month in your pocket. You know, that might not mean a lot to a lot of folks. But $10 a month can be significant for others. So again, that, you know, builders would whine about the $2,000, but the builder is going to charge an extra $2,500. So the builder doesn't pay it, the homeowner pays. Well, the homeowner, you know, if they knew the math, they would be happy to pay the extra money, because from the very first month, it will pay for itself. And there's federal legislation in place such that the national labs have to do these calculations, and you can't, it's such that 100-year paybacks on things in the energy code don't make it in there. It has to be proven cost effective. There is cost effective analysis of every edition of the energy code. This is I stole this slide out of Texas A&M's Energy Systems Lab. Again, they are responsible. So what Energy Systems Lab has to do, a handful of things, of course, that they do more than just this, but TERP has mandated that they figure out how much. So if obviously builders don't want anything to change ever, right? Well, this is the year 2000 right here. So if we would have left construction requirements at 2000 for homes, we would have cruised right along at this bottom line with no energy, no millions of dollars in energy savings. Well, as we've increased the stringency of the energy code over time, you can see what the different savings measures have done. And this will keep ramping up like this over time. And this is basically all, and you look at the NOx reductions equivalent to 80,000, over 80,000 cars off the road, just increased stringency in energy codes since the year 2000. Has it been more expensive? Yes, it has been more expensive, $2.3 million more approximately, but we've saved approximately 8.6 million. So it absolutely makes sense. And, you know, we all remember Snowmageddon, right? I mean, I lost power for 36 hours. My house was built in 1997. I sure wish I had a better building thermal envelope and a more efficient home. I can assure you that. So that's where we're headed. And it's not, we haven't gotten crazy yet. You know, we don't require passive house standards. There's not an R60 wall or R100 ceiling. There's no ridiculous requirements. You can see in climate zone 2 that it's still an R13 wall is allowed. So it's not that difficult, especially for climate zone 2. Excuse me. Okay. So I like this slide when I'm talking just kind of generally about energy savings. As far as carbon dioxide emissions, look at where we're at with Texas. This is a little dated. It's about 7 years old, but coal, natural gas, petroleum, we're double all the other states except California. So we need, and again, 40% of energy use is in buildings. So if we can make buildings use less energy, it's a big helper with this. And this one's another fun one to look. There's an energy assumption in quadrillion BTUs. I love it that it's China, United States, Russia, all these big countries, and then Texas. I just think that's kind of funny that it almost meets Canada or Germany, you know, entire countries. So that's kind of the Energy Code 101. Again, I know that that's clear as mud, and certainly if you do not work with construction codes, I know plenty of people that do work with construction codes and still are confused about the energy code. And my goodness, I've been supposedly an energy code expert for 6 years now, and I had to reread through the skylight section of the code today. I read it 5 times and I changed my opinion of it, what it says 5 different times. So it's certainly not simple, but we're off of that. Now we're going to talk about, okay, so that's great. New construction has to be built to the energy code, but how do I save some energy in my house? That's, you know, that one's a little trouble there. That was actually a house I demolished in Temple, Texas, if I'm not mistaken, where I was housing official. Demolished 72 homes in like 2 years there. Step number 1, call your energy provider. you would be shocked at what your energy provider can do for you. Unfortunately, our energy providers aren't statutorily required to invest in energy efficiency like those in the Northeast or Northwest are. But a lot of times that they'll do it anyway, or they still will do it at a smaller percentage, or they might have other programs just because they want to lessen the strain on their grid. So the very first thing to do, call your energy provider. You'll be shocked at, I mean, I called mine when we moved to San Antonio. We've been here about 3 years ago. They came out. I got a couple of brand new Wi-Fi thermostats for free. They will come typically do a full assessment of your home. I'm talking about crawling up in the attic, looking at your windows, looking at your walls, looking at everything, looking at your HVAC unit. And like me, for instance, both of my AC units are original to this home, which was built in 1997. So I'm going to need to be replacing them probably pretty quickly. Well, before I just call an HVAC company and have them install the cheapest unit that I can afford, you know, which is probably be, I mean, maybe not quite as low as I could with a 14 SEER, I would probably bump up to at least a 16, but I wouldn't spend extra money on a more efficient piece of equipment just because I can't really afford it, right? Well, but what if I call CPS Energy, which is my energy provider here, and they say, oh, hey, we have a $600 rebate if you go 18 SEER or higher. Well, if the 18 SEER is only $600 more expensive and I get a $600 rebate, well, then it's not really more expensive, right? And so that they offer rebates. They brought me a case of LED light bulbs, on and on and on. Call your energy provider, step one. Step two, think about heat flow. So heat is remarkably consistent. It will always travel from hot to cold. Heat always does that. Whether most people think, oh, heat always goes up. No, not if it's hot up and cold down, heat goes down. Heat always travels from hot to cold. It typically does rise as well, but what it always does is travel from hot to cold. I know in my house, again, built in 1997, if you had a house built in the 90s or up to mid, maybe even late 2000s, you probably have can lights that look like this. You can tell that they are not, this can light should actually not be in contact with insulation. If you see these big holes cut in your can light, but that's for air to cool the bulb, you know they are not what's called IC rated or insulation contact rated. Couple of problems. So if you look up at your can light and you can quite literally see these holes, or you look down from the attic and you know your attic's dark and the room's lit up, you'll be able to see light shining through these. Well, hot air from your attic also just goes through there like a superhighway. Well, they make these little LED retrofit kits. I've got enough time. Let me show. It's a 2-minute video. I'll show you how unbelievably simple it is to swap these out.
If the lamp and trim are already installed, they need to be removed. Next, slide the lamp holder bracket check the height of the bracket to the instructions on the instruction sheet and make sure the height is at least the minimum dimensions shown. If not, the lamp holder bracket needs to be removed and the label placed on the recessed fixture as I'm showing here. The lamp holder adapter then is installed into the lamp holder. then the electrical connection is made to the recessed trim. Next, the torsion springs need to be installed into the brackets in the recessed fixture.
Super easy. You just get those springs right in there.
That's one. And the second one needs to be installed the same way. Be sure to tuck the adapter out of the way and install the second torsion spring.
And that's going to, and then it pushes flush against the ceiling. And so you have a seal here, and you notice there's no holes here, right? Whereas on that can light before, if you'll notice, if you've got the old ones, you can see your bulb and then the housing, and it is a direct pathway to your 140-degree attic. And again, I mean, when you're thinking about heat flow, it's always, delta T is what you're thinking of when you're doing the math. But what I take, just to kind of dumb it down and keep it simple, the bigger the difference, which yes, it gets 105 degrees outside, but it doesn't get 145 degrees outside. Your attic gets 145 degrees though. And so that's going to be the biggest highway, so to speak. That 145-degree attic trying to come into your 75-degree home. Well, if it has a bunch of air holes to cool that old incandescent light, and it's quite literally a direct path, so you're kind of killing three birds with one stone. One, you're switching from an inefficient bulb to an LED. Two, you're changing the dynamics of this can such that you can just insulate against it because it's not going to get as hot with the LED. And then three, you're getting that air seal up against your drywall. So, air infiltration is your #1 energy penalty. Great time to do this if you're going to paint your ceiling. Oh, no, wait, that's not what this is about. And another thing to think about, if you ever do paint your ceiling, when you remove your HVAC diffusers, you'll notice where your HVAC boot touches your drywall, there will be a crack around there, where they cut the drywall to put the boot through. Well, if you're painting your ceiling anyway, you've taken all that stuff. You've taken the trim off your exhaust fan in your bathroom. So all of those penetrations in your ceiling, which is typically your #1 air leakage place. And we already said air leakage is your #1 energy penalty. An 88-cent tube of latex caulk, you caulk all of those penetrations, from the exhaust fan to the drywall. Now, if you do these retrofits, they have a little sponge gasket, and so you don't really have to caulk those because that gasket will seal it. But the HVAC diffusers, there will be a gap there. You caulk all that, you reduce your airflow. And if Sean sends you a PDF, there's a couple of hyperlinks here, so you'll have a hyperlink to that video if you want to watch it. But these things right here are about, I think I gave $14 for 2 of them, so about $7 a pop. And it's the whole retrofit kit that does all that for you. If you're thinking about what's in my walls, do I need to worry about increasing insulation in my walls? Well, that's a little bigger job, right? Because you can't, it's not just a simple retrofit kit kind of change out, but you can get an infrared gun, a pretty cheap one, a decent one for about $60 these days. Well, this is an infrared shot of a wall. Well, we can see here that they didn't insulate in this stud cavity whatsoever. This is probably a blown in fiberglass insulation, which is settled in this stud cavity. So if you're kind of wanting to go that next step, checking your walls, and if you see a bunch of this on a cold day outside, well, it might in a whole bunch of your wall, maybe especially if you're thinking about repainting anyway, you can drill a little 4-inch diameter hole in the top of each stud cavity and in the bottom, and fill the stud cavities with fiberglass insulation. That's a great way to do it. And kind of looking at what it means, we saw the gap, in the whole area of this wall, that's maybe only 2% of the total area that has gaps. Well, this is from a presentation I do about insulation installation. Well, if you look at an R13 wall, if you only have 2% gaps, that's an R11. Well, you go up into your attic, and again, where you've got that super highway of 145-degree heat trying to scream into your house. Well, maybe this is, you've got a 14-foot ceiling in your living room with this vault ceiling here. So this would be ceiling to your living room, and you've got an 8-foot ceiling down here. So they insulate this wall. Well, they insulate this wall with R13. That's not very good, right? The rest of your ceiling has R38 or R30. Well, where you miss this, long story short, an R30 attic with just 4% of gaps, you can see how it will perform. It'll perform like an R13. So the whole importance of this is go up in your attic, especially you'd call these a knee wall, a vertical wall in the attic. That's going to be your number one, that heat super highway. And what you might want to do for $8 and change, you can get an R3. I just bought some the other day, R3.2. It's a 4x8 sheet of foam insulation. You don't need any specialized tools. You can cut it with a utility knife. You can install it with just some cheap 1.5 inch, 1.75 inch roofing nails, piece of cake, like right here. Again, so we've got our 14-foot ceiling in our living room here, and our 8 or 10-foot ceiling or whatever it may be here. Ceiling differences. So this is up in an attic. Well, if I have, a 2x4 stud is about a R3.5 thermal resistance. Well, you can, and your studs are about roughly 20 to 25% of the wall. So let's say 20% of your wall is R3.5. And even if you had an R13 bat in there, 75% of your walls are R13. Well, if you can double the thermal efficiency of your wall by putting an $8 sheet of foam on there, not only that, that also qualifies as a rigid air barrier. So you're stopping that movement in the attic air that goes through that 3.5 inches of fiberglass. This stops that. Additionally, it creates a dam such that you might want to go back and blow additional blown insulation in there. Well, rather than this insulation falling off this top plate into this attic area, it actually allows you to keep the full depth of insulation here. You notice, like, again, this is, a vaulted ceiling typically is where you see this, or on ceiling change, but look at what this cold attic looks like just because not having a rigid air barrier on the back side of that. So that's a great way to do it. Anywhere you have knee walls in the attic, going back, and for $8 a sheet, you can double the thermal resistance for 20% of the wall and add R3, or, they make it inch thick, R5, you can get it in R10. It's a little pricier, but shoot, for $8 a sheet, that 1/2 inch foam works great. It's easy to install. That would be kind of one of the very first things I did. This will be another video. It's a 20-minute video, so I'm not going to play it. But if you've got a really older home and just kind of maybe the next step, going even further, wherever you have these penetrations in, here's a top plate, you could get your blown insulation out of the way. There's a couple of things you could do. So you could go back and vacuum up all this blown, foam your roof line. That would bring your mechanicals into conditioned space. That would save you a ton of money. That's a pretty expensive retrofit. It's not that expensive to pull your blown insulation away from the things that penetrate it. Again, it's cheaper and easier from underneath, but this just shows sealing that penetration. This is an exhaust fan, sealing that penetration. Our attics are notoriously underventilated. And so these are what are called insulation baffles. So a lot of times, imagine, this is a ceiling. So after drywall gets put on these trusses, you're going to blow, with the new energy code, R49 on top of them. With the older energy codes, the 15, the 18, the 12, you're going to blow 12 inches. So R38. Well, if you don't have these baffles in here, what happens over time is the wind comes in through your soffit and comes down through your ridge vents. And that blown insulation blows back off the top plate and blows down into the soffit. Well, these baffles allow your attic to stay ventilated. which makes a big difference. I mean, it can lower your attic 15, 20 degrees easy, a properly ventilated attic. It keeps the full depth of insulation over the top plate and around the edge of your house. And then you can go back and fairly cheaply. I know when I added insulation to our house in Mississippi, and especially if you need to increase your storage, well, you can go where you have your 2x6 joists in your attic. You can go back with 2x6s perpendicular, deck and then fill all that 12 inches with blown, and then deck the top of that. You're increasing attic storage and creating an air barrier to help stop that airflow. So that's kind of the a little more money, but if you buy the blown insulation from like Home Depot or Lowe's, I don't know if Lowe's does it or not, but I know Home Depot certainly at least used to. You can go buy bagged blown insulation and they will lend you the machine that blows it for free. And so I bought like 10 bags of blown insulation. I added those joists perpendicular to my existing so I could deck it when I was done. And for, I think it was $500. It wasn't even that much. I remember the rebate from my utility more than covered the cost of the additional blown insulation. So that's a pretty cheap, easy way to increase insulation in your attic. If your attic access is in conditioned space, you've got a scuttle hole in a closet, or you've got a pull down stair in the hallway, or whatever it may be, those are notoriously leaky spots. Adding an insulation dam around your scuttle hole such that you keep that full R38 around the perimeter, putting some weather stripping on your scuttle hole hatch, and maybe you attach an R38 bat to the back of it. If you want to replace, if maybe your attic access pull down stair is scary and you don't like climbing up and down that thing, this is actually an R10. It's all built into the pull down stair. Marwin makes this. It's manufactured in Texas. I always like buying Texas if I can, but this is a great product, not that expensive at $300. I mean, pretty doggone cheap. They make these attic tents that you can put on an attic stair. But basically what you want to think about is stopping the air leakage. So get you some weather stripping, and then increasing the insulation level. Because again, that 140-degree attic in your 75-degree house. I have this problem in my house. This is another slide from my insulation installation presentation. And imagine this being your second floor, and then down here's your first floor. A lot of times, this is how my insulation is installed in my house now. I can't believe I've lived here 3 years and still haven't fixed this yet, but I haven't. But what you'd want to do, so you might not be able to crawl into that floor joist cavity and push that insulation up and use a wire stay to keep it pressed up against the floor. You can quite literally, the floor in my attic is warm right now because of my warm attic. But what you can do is at the end of this floor joist cavity, you can install a 2x6 block to stop the hot air from flowing into that cavity, block it, and then insulate the outside of that block. And you kind of solve that problem by doing it that way. If you want to kind of go next step, you can have somebody come out and test your ducts. This is what a duct blaster looks like. It's basically a fan hooked up to your duct system that pressurizes it to see how leaky they are. Or I know just the other day, I was up in my attic repairing the condensate line that was clogged. I noticed my secondary condensate was dripping. And so I knew my primary condensate line was clogged. And I go up to my air handler in the attic, and one of my ducts had actually, this Grace material is called mastic. One of my ducts had actually come loose from the supply plenum, and I had about an inch gap of conditioned air just blowing into my attic. You can get a 3-gallon pail of mastic for $10, $12. All right, go up to your air handler in your attic and just run your hand around where all your ducts connect to your plenum. This is called a plenum here. Or a lot of times the seams on your plenum, especially if they just taped them instead of masticing them, will come loose. So just feel all around there while your air conditioner's running. In mastic, I mean, you can slop it on with a rubber glove. You can get an old cheap paintbrush. I mean, it applies. It's super easy. It's like a kind of has like a clay consistency, and just smear it all around on your ducts. Now you'll want to turn your AC off and give it, I think it dries in 45 minutes or so. Read the bucket, but I didn't wait longer than 45 and it held on mine. So sealing your ducts, getting all your conditioned air where it needs to go. Cleaning your coils. Now, a maintenance contract with an HVAC company is always a good idea. If you can't really afford a maintenance contract, once a year, I do this once a year, every year. Get my power head on my hose, and this is a coil. So this is your heat exchanger. This is what helps turn that hot air into cold air. And this is what a coil can look like over time, especially if you've got a real, you know, your grass is all brown and dry, and when you mow this, you blow all that dust up into your coil. I'll take that pressured water hose and just kind of slowly go back and forth into each of these cutouts here, all the way around my condenser, whoops, and clean the coil. Because when your coil looks like this, it won't cool. Maintenance is crucial. Change your filters, clean your coils. Those are the two biggest. And I always, a couple of times a summer, pour a little bleach in my condensate line to make sure the primary doesn't get clogged. Return air, our return air, I mainly put this one on is because I look for any excuse I can to put that picture on here. But this is a return air. Return airs are typically undersized. And so if you are doing an HVAC change out, you're getting a new unit, talk to the HVAC contractor and just say, hey, do you think I need a little more return air? And your unit might work a whole lot better with just $150 worth of another duct run to the master to add to the return air. Worst case scenario, fuse you in a cooler, put some dry ice in there, problem solved. These two rooms are cooler. My wife would be wondering, I quit drinking beer, honey, I swear. Well, this would keep it cold in your attic. That's just tips and tricks. Here we go. We're learning them all. Again, this is back to your utility provider offering incentives. You know, the cheapest builder grade electric resistance hot water heater, it's going to cost you, for a family of 4, a little over $600 a year to operate. A nice heat pump water heater is about $700 more. I know for a while, Austin Energy was offering a $600 rebate. Well, if I can pay $100 more to get a efficient heat pump water heater, look what an Energy Star heat pump water, this is a year, under $300 a year, over $600 a year. So in 1 year, you're going to save $300. You can get 10 years out of a hot water heater, $3,000 in savings. So even if this thing is $1,000 more and your utility doesn't have a rebate, if you can afford that extra $1,000, heat pump water heaters make a lot of sense. And if it's installed in your garage, I really like the idea of, I mean, how they work. They take hot air in and exhaust cold air out. Hey, lowering my garage temperature a few degrees, great thing to do. Some other steps. When you're purchasing new appliances, always look for the Energy Star label. Of course, consider renewable. Solar is getting cheaper and cheaper. To me, way before I thought about putting on solar panels, though, I'm going to increase my insulation levels. I'm going to do that air sealing. I'm going to put in LEDs, that low-hanging fruit first, and then solar. Lifestyle changes. You know, can you wear a sweater in the winter rather than keeping it on 78? You know, in the summer, I very rarely have a shirt on in the house, and it's just, you know, running around with no clothes, you know, or you'd be amazed at, I mean, I keep it 76, 77, 78 in my house during the day. People say, oh, that's too hot. Well, go out and work in the yard from noon to 1 when it's 100 degrees outside. 78 feels pretty doggone cool. So think about lifestyle changes. If you're doing some plantings, especially on your west facing windows, especially if you've got a 10, 15, 20, 25-year or older home, creating some natural shading for your west facing windows will stop that solar heat gain through that glass. Window shades can help. YouTube and Google, right? Super helpful, but be careful. They can offer you some bad ideas. I think that's funny. I stole that meme. I don't remember who I got it from. And that's it. And look at that with 5 minutes to go.
Great job, Jason. I learned a lot. And I like your images at the very end. Even though your presentation did add to my honey-do list for my house. Thanks a lot.
Sure.
So does anyone have any questions? I haven't seen any sent over.
There's a few on the chat. Let's see.
Oh, I actually had a question I sent over to you. What should you do for pier and beam houses?
Well, and that you crawl up underneath them, and what you will often find, and it kind of goes back to, let's go back to that slide. What you'll find a lot of times in pier and beam houses is these wire stays on your bat insulation up on the floor have come loose, or you've had a coon in there that busted it loose or whatever. Now, crawling under the house is one of my least favorite things to do. Maybe you've got a teenager or something, then they got in trouble, that you can make go under there and take a look at everything. But you'll be surprised how often your floor insulation has come loose. That would be a great thing to do. Kind of the one tier up, you could, if you don't, a lot of times you don't have any insulation under there at all. And you could get a spray foam contractor to come in there and foam that. And that's going to do two different things. One, it's going to give you insulation. And then two, it's going to air seal. So that's going to be super handy. I personally think humidity control bathroom vents are worth the money, just because if your significant other is like my wife and likes to take a 30-minute hot, steamy shower, getting that humid moisture, hot, humid, moisture-laden air out of my bathroom. And now what I would say, if you do change a humidity control bathroom vent, if you do swap out your bathroom exhaust for a humidity controlled vent, so basically what that does is that's going to exhaust the hot and the humid. It's code says, and it's said this for years and years and years, but I've written 100 red tags about it. And actually the ones in my house are like this. A lot of times they just run that exhaust duct up into your attic, and you really don't want to be exhausting that moisture up in your attic. So you want to make sure that that duct has been run to the outside. If you don't want to cut a hole in your roof, which I wouldn't want to, you can at least make sure that that duct is run over into your ventilated soffit. That at least gets it semi to the outside air. Low speed, high volume hand fans for the house. That's going to depend on the house and the climate zone, how leaky your house is. That's probably going to be a house by house basis. I'm not a fan of power vented attic fans, because there's just too many things that can go wrong with that. Now, me personally, when I'm getting a new roof, adding some mechanically ventilated fans like a whirlybird that just rely on the heat and the hot air, that they kind of slowly draft air up through your soffit vents. I mean, you can backdraft gas combustion appliances. You can actually, those power vents in attics, a lot of times what you'll have happen is it actually will end up sucking your conditioned air out of the house as well, because you actually have more air leaks between your house and the attic than you do between your ventilated soffit in the attic. If you were going to add a power vent for your attic, you would want to make sure that you have a ton of soffit vent openings, and you would want to make sure that you sealed all those penetrations in your ceiling so that you're not sucking out your cold air. And we finished right on time, Sean. It's like we know what we're doing, 11 o'clock on the dot.
Well, thank you all for joining us. I'll be sending out an email with resources. And again, please fill out the survey. I threw it in the chat. And thanks, Jason. I hope you all learned something, because I know I did. Bye.